Welcome back, guys. Our last week of videos for term 2 before we get on to our revision, and we're looking at factorization today, or factorizing or factoring. Not sure why there's a difference between factoring and factorizing, but it seems to be out there. Anyway, what is it that we're about when we're trying to factorize expressions? Factors, you would have heard the term before. Factors are where things are being multiplied together. The factors of 6 are 1 and 6, 2 and 3, because 1 times 6 equals 6, 2 times 3 equals 6. We're going to try and separate algebraic expressions into factorized expressions. So we'll have a look at a couple of examples, and I think that's the easiest way for you to get a feel for what I mean. This is a really important skill because later on it enables us to solve equations with variables where the powers are greater than 1. So when we might have an x squared or an x cubed term, something like that. So we're going to go ahead and look at exactly how we do some of the easier types of factorizing first up. These first questions is just looking to determine the highest common factor, because that's our first step in factorizing. We like to find the highest common factor of the terms involved. Looking here on the left, you see we've got 6a and 8b, and I was about to highlight that. I'm not sure why it was still on a highlighter. Let's try a different coloured pen. So first of all, you just start looking at the numbers. What number goes into both 6 and 8? Obviously, the largest number that's a factor of both of those is 2. They're both even. And then you look at the letters. This 6 is being multiplied by A. The 8 is being multiplied by both A and then B. So A is common. So 2A would be my highest common factor. When we have a look at the next one, I've got 3x squared plus 6xy. Again, just do numbers and numbers first, then letters and letters. So the highest factor of 3 and 6, highest common factor, is indeed 3. That doesn't look like much of a 3. Maybe a little bit better there. And here we've got an x squared, so that's 2 x's being multiplied together, and here we've got an x and a y being multiplied together. So of course, the one that they have in common is an x. So the highest common factor in each of those cases, in the first case 2a, and in the second case 3x. You need to try a couple of these yourself. There's a couple on the right hand side for you there. Pause the video, have a go at those two. Shouldn't take you long. You can even just think about them in your head and then just check that you got them correct before we move on. And there you go, 2x and 5x being the answers in those cases. It won't always be that they're both a number and a letter. It might be just a number, it might be just a letter. It might be a combination of numbers and letters, as it was in those two cases. So that's our first step, finding the highest common factor. How do we complete factorizing? Well, let's have a look in these next two, and I think that'll give us a good idea. So here we've got 40 minus 16b. Now, I've got to find the highest common factor again. It's tempting to just say, oh, they're both even, so 2's the highest common factor. But I think if you know your times tables well, 8 is going to go into both 40 and 16. And then when I'm looking for letters, well, the first term, the 40, doesn't have any letters. So it can't have any letters in common with the second term, the negative 16b. So 8 is my highest common factor. And here's what we do. We say this is equivalent to, or this is equal to, 8. That's my highest common factor. You put the remaining factor from each term inside the bracket. So to get 40, that was 8 times 5. So I need to have a 5 here. So when I expand my bracket, 8 times 5 would give me 40. There's a minus sign there. 8 times what is going to give 16? That's right, it's 8 times 2. And I need a b there as well. So inside the bracket, we have 5 minus 2b. Have a quick check. Expand it in your head. 8 times 5 would give 40. Yep, that's right. 8 times negative 2b, negative 16b. Now this is a factorized expression because I have a one term, or one factor, the 8, multiplying another factor, in this case 5 minus 2b. So that's a factorized expression. It's the opposite of expanding that we've been doing. Second case here, oh, they've both got a negative. It's always a good idea if they're both negative to take that negative 1 out as a common factor. I can also look ahead though, it might not just be 1. We might be able to find a common factor with the numbers here. 8 and 12, their highest common factor is a 4. Looking at the letters, the first term has an x squared, the second term has an x, so they have 1x in common. So my highest common factor there is negative 4x. What can I put in to make sure that this is still equal? Well, I need to have a total of negative 8, so that's going to be negative 4 times 2. And x squared, I've got 1x, it needs to multiply another x to give me x squared. If I expand that, negative 4x by 2x, I'm going to get my negative 8x squared. Still have to do the 12x. I've got negative 4x. So the negative's taken care of. 4 times positive 3. So negative 4 times positive 3. That's going to give me the negative 12. The x is already taken out the front. So that's what's remaining. Again, check by expanding. You'll see that we get negative 8x squared minus 12x there. As always, a couple for you to try. Have a go at those now, and then check back and see how you went. And there you have your answers there. Again, nicely factorized. 7 multiplied by 4 minus 3a, and then negative 3x multiplied by 3x plus 5. Only a couple more examples. I'm thinking you guys are going to be pretty good at this. Sometimes it's a little bit sneaky what the common factor looks like. Here I've got 3 multiplied by a term in brackets, x plus y. And then I've got plus x multiplied by x plus y. Now, even though there are brackets there, this is not a factorized expression because not every term is being multiplied together. It's not just a list of factors being multiplied. There's an addition in there, a plus sign. Same with the one below it, there's a minus sign. So we need to try and write them as just things being multiplied together. The 3 doesn't seem to have anything else to go with, so that can't be part of my common factor. But what is part of my common factor is the entire bit in brackets there, the x plus y. That's common in each term. It's common to both terms. There's an x plus y in the first term and an x plus y in the second term. So what do we do with our common factors? We put them out the front. And if it's a bracketed term, that's okay. We just put the bracketed term out the front, just like we do with any other common factor. What was left over in my first term? Well, it was supposed to be being multiplied by 3, so I need a 3 there. And in my second term, I need an x. So that would be the factorized form there. X plus y multiplied by 3 plus x. Likewise, this second one down here, you can see the bracketed term is the same. It's a 7 minus 2x. And what are the leftover terms? Now here's a little trick that sometimes catches a few people out. I've put this out the front. Is there anything left there? No. So people just say, oh, well, I don't need anything there. And then there's a negative x on the end, so I just need a negative x inside the bracket. If you try to expand that now, though, you're only going to get this right-hand term. What you need to remember is, if there's just a bracket on its own, there's a 1 in front of that, isn't there? There's one of those brackets. It is there. So we need to remind ourselves to put the 1 in when doing our factorizing. If you do that, you can't go wrong and you'll be getting the right answers. All right, have a go again. 2 for you to try. And then you'll be on with the exercise. Don't forget to do the quick points. It's important to keep that revision up. And to do your form when you're done. I'll pause now. You can come back and check these answers. And then you'll be done. All right, hopefully you found that okay. Remember, any questions, pop them into the collaboration space or put them in on Teams and we'll be able to help you out. Keep up your good work. Get stuck into the work today. Have fun. Cheers, guys.